In section 10.5, we are rationalized denominators and rationalizing denominators having two terms. Rationalizing denominators means we're trying to get rid of any square root or radical sign in the denominator. For these problems, we want to rationalize each denominator and assume that all variables represent positive real numbers. For example A, we have 3 divided by the square root of 5. To rationalize the denominator, we want to multiply the numerator and the denominator by a quantity that would make the denominator result with no radical signs. And we can do that by taking our fraction 3 over the square root of 5 and multiplying the denominator by square root of 5. So that will be the square root of 25, which is 5, a nice whole number without any radical signs. But if you're dividing the denominator by, or multiplying the denominator by square root of 5, you have to multiply the numerator by the square root of 5 as well. Otherwise, you're changing the value of the whole quantity. So when we multiply the numerator by square root of 5, we get 3 times the square root of 5, and the denominator is square root of 5 times the square root of 5, which is the square root of 25. But that can be simplified, so we have 3 times the square root of 5 in the numerator over 5 in the denominator. So we say that this denominator is rationalized because the denominator does not have a radical sign. Let's look at example B. We have the square root of 1 over 7. Well, that's the same thing as the square root of 1 over the square root of 7. And since the denominator has a square root of 7, we can multiply the numerator and the denominator by the square root of 7 so that we end up with the square root of 1 times the square root of 7 is the square root of 7 in the numerator. And the square root of 7 times the square root of 7 is the square root of 49 in the denominator. We can then simplify this so that our numerator is the square root of 7 and the denominator is 7. So that is our final answer where our denominator is rationalized. In example C, we have 6 divided by the cubed root of 4. So we want to multiply the numerator and the denominator by a quantity that would result with no radicals in the denominator. So since we're dealing with a cubed root of 4, and 4 is the same thing as 2 times 2, we want to multiply something 4 by something to make it a perfect cube. In this case, we're going to multiply the cubed root of 2 in both the numerator and the denominator. So in the numerator, 6 times the cubed root of 2 is 6 times the cubed root of 2, and in the denominator, the cubed root of 4 times the cubed root of 2 is the cubed root of 8. Now since 8 is a perfect cube, the denominator then will simplify so that we get our expression as 6 times the cubed root of 2 in the numerator and 2 in the denominator, because the cubed root of 8 is equal to 2. Now we can simplify one step further. Since 2 is an even number, 6 is an even number, we can divide those out so that we end up with 2 goes into 6 3 times, and we end up with our final answer of 3 times the cubed root of 2. In example D, we have 5 divided by the square root of 18x. So what we need to do is multiply the numerator and the denominator by something that would make the denominator rationalize the denominator, so what's under the radical is a perfect square. We can do that by multiplying by 18 by something that makes it a perfect square. If we multiply 18 times 2, we get 36, and that's a perfect square. And then we also want to multiply by x, because x times x is a perfect square as well. So we're multiplying both the numerator and the denominator by the square root of 2x. When we simplify this, we get 5 times the square root of 2x in the numerator, and in the denominator we get the square root of 18x times 2x. Well, 18 times 2 is 36, and x times x is x squared. So we are nearly there in simplifying this so that we end up with no radical signs in the denominator. So our numerator is 5 times the square root of 2x, and then the denominator, the square root of 36 is 6, and the square root of x squared is x. And again, we're assuming that the variables represent positive real numbers, so we can write this as our final answer, 5 squared root of 2x all over 6x. In example E, we have negative 7 radical 3 divided by radical 11. So what we want to do is take and multiply the numerator and the denominator by something that makes the denominator a simplified form without radicals, and we can multiply by the square root of 11 in the numerator and the denominator. When we do that, we get negative 7 square root of 3 times the square root of 11 is negative square root of 33. And in the denominator, the square root of 11 times the square root of 11 is the square root of 121. And that's a perfect square, so we can simplify that to get negative square root of 33 in the numerator over 11 in the denominator as our final answer. For example F, we can write this as the square root of 23a in the numerator over the square root of 2b in the denominator. So to rationalize the denominator, we're going to multiply the numerator and the denominator by 2b, the square root of 2b. And then we get the square root of 23a times the square root of 2b is the square root of 46ab in the numerator. In the denominator, the square root of 2b times the square root of 2b is the square root of 4b squared, which we can simplify the denominator so that our answer is the square root of 46ab in the numerator, all divided by 2b in the denominator. In example G, we have the cubed root of 10x divided by the cubed root of 5y to the fourth. So we can approach this problem a few ways. In fact, I can write this entire quantity as a cubed root of 10x over 5y to the fourth, so we can simplify the 10 and the 5. By doing that, we get the cubed root of, since 5 goes into 10 twice, the cubed root of 2x over y to the fourth. Now we can write this as the cubed root of 2x in the numerator and the cubed root of y to the fourth in the denominator. And we rationalize the denominator by multiplying by something that makes this, the radicand, a perfect cube. Since we have y to the fourth, I can multiply by the cubed root of y to the second. That'll give us a y to the sixth, which is a perfect cube. And we multiply both the numerator and the denominator by the cubed root of y squared. When we do that, in the numerator, we get the cubed root of 2x times the cubed root of y squared, results in the cubed root of 2xy squared. And in the denominator, the cubed root of y to the fourth times the cubed root of y to the second is the cubed root of y to the sixth. And then we can simplify this. Our numerator is the cubed root of 2xy squared, and our denominator is y squared. The cubed root of y to the sixth is y to the second power for our final answer. For these examples, we want to rationalize each denominator, but in each denominator we have a binomial. So in order to rationalize, we need to multiply by the conjugate. As you can see in the yellow box here, we describe what conjugates are. When the denominator of a rational expression is a binomial that contains a radical, the denominator is rationalized. This is done by using the conjugate of the denominator. The conjugate of a binomial is a binomial having the same two terms with the sign of the second term changed. For example, the conjugate of 5 plus the square root of 6 is 5 minus the square root of 6. And the conjugate of the square root of 3x minus the fourth root of 2y is the square root of 3x plus the fourth root of 2y. These are conjugates. It's a binomial having the same two terms, but the second term is changed. Let's use this process to rationalize the denominators for these examples. In example A, we have 2 divided by the square root of 5 minus 4. To rationalize this denominator, we're going to multiply by the conjugate of the square root of 5 minus 4, which is the square root of 5 plus 4. And we're multiplying both the numerator and the denominator by that same conjugate. In the numerator, we're going to use the distributive property to get 2 square root of 5 plus 8. And in the denominator, we need to use our first, outer, inner, last. Since we're multiplying a binomial times a binomial, we're going to use FOIL. So the first is the square root of 5 times the square root of 5 is the square root of 25. The outer square root of 5 times the plus 4 is plus 4 square root of 5. The inner is minus 4 times the square root of 5 is minus 4 square root of 5. And the last is negative 4 times positive 4 is negative 16. Let's simplify this so that in the numerator we get, let's simplify. Our numerator is 2 times the square root of 5 plus 8. And then the denominator, the square root of 25, is 5. The middle two terms, the plus square root of 5 and minus square root of 5, are opposite, so they're going to subtract out. And we have 5 minus 16 in the denominator, so we can simplify one step further. 2 radical 5 plus 8 in the numerator over negative 11. Or you can write this as a negative out in front of the whole fraction, 2 square root of 5 plus 8 all over 11, or you could distribute that negative in the numerator. So either one of these is appropriate for our final answer. Let's continue with example B, where we have negative 6 divided by the square root of y plus 3. We're going to rationalize the denominator by multiplying by the conjugate of the denominator. We're going to multiply the numerator and the denominator by the square root of y minus 3. We can use a distributive property in the numerator to get negative 6 times the square root of y plus 18, all divided by square root of y plus 3 times the square root of y minus 3, using first, outer, inner, last. The square root of y times the square root of y is the square root of y squared, which simplifies to y. The outer is minus 3 square root of y, the inner is plus 3 square root of y, and the last is minus 9. And whenever using the conjugate, those middle terms are always going to be opposites, so those will always simplify. And we can write our answer here as negative 6 square root of y plus 18 in the numerator and y minus 9 in the denominator. Let's simplify the square root of 2 plus the square root of 4 all over the square root of 3 plus the square root of 2 by multiplying the numerator and the denominator by the conjugate. So we start off with the square root of 2 plus the square root of 4 all over the square root of 3 plus the square root of 2. Now I can simplify. The square root of 4 is 2, so I can write that as a 2 there. Now we multiply the numerator and the denominator by the conjugate, which is going to be the square root of 3 minus the square root of 2. And we're going to multiply both the numerator and the denominator by that conjugate. Now we can use the FOIL process, first, outer, inner, last. Square root of 2 times the square root of 3 is the square root of 6. The outer is square root of 2 times a negative square root of 2, which is a negative square root of 4. The inner is plus 2 square root of 3, and the last is minus 2 square root of 2. In the denominator, first, outer, inner, last. The square root of 3 times the square root of 3 is square root of 9. The outer is minus the square root of 6. The inner is plus square root of 6, and the last is minus the square root of 4. Let's simplify the numerator and the denominator. We have the square root of 6 minus 2 plus 2 times the square root of 3 minus 2 times the square root of 2. Now this cannot be simplified. There are no like terms. In order to have like terms with radicals, you have to have the same index and the same radicand, and that's not the case for any of those. In the denominator, we can simplify. Those middle terms are always opposite, and we have the square root of 9, which is 3. The middle terms will cancel out, and minus the square root of 4 is minus 2. So in the denominator, we just get 1. So our final answer can be written as the square root of 6 minus 2 plus 2 square root of 3 minus 2 square root of 2, with a 1 in the denominator, which is just simplifies. All right, now let's look at example D. All right, we're going to simplify this rational expression where in the numerator we have 3 square root of x minus 2, and in the denominator we have 3 square root of x minus the square root of y. we're going to multiply the numerator and the denominator by the conjugate of the denominator, which is 3 square root of x plus the square root of y. And we're going to use the FOIL process in simplifying the numerator and the denominator. 3 square root of x times 3 square root of x is 3 times 3 is 9. And square root of x times the square root of x is the square root of x squared, which we'll be able to simplify. The outer is 3 square root of x times square root of y is plus 3 square root of xy. The inner is minus 2 times 3 square root of x, so that's going to be minus 6 square root of x. And the last is negative 2 times square root of y, or minus 2 square root of y. In the denominator, first, outer, inner, last, 3 square root of x times 3 square root of x is 9 square root of x squared, which will simplify. The outer is plus 3 square root of xy, the inner is minus 3 square root of xy, and the last is minus square root of y squared. Let's simplify. We shouldn't end up with any radicals in the denominator. In the numerator, we get 9x plus 3 square root of xy minus 6 square root of x minus 2 square root of y. And in the denominator, we get 9x. Those middle two terms are opposites. They cancel out. Minus y as our final answer when we simplify the rational expression by rationalizing the denominator.